Very good morning, IB to all. Okay, so today we will be presenting our group project that we currently choose, which is the high tower crane by group 1. Okay, next, please. Okay, as you all can see, this is our team, which consists of me, Akif Hakimi Biasa Mariza, Muhammad Hanafi, Hafizuddin Aziz, Nurul Aina, and also Farah Shamimi. Okay, the next one. Okay, this is the table of contents for our slide presentation. Okay, next. Okay, now I pass on to for the introduction.
Okay, so first and foremost is tower crane is a common piece of lifting equipment found on construction site. So the function is to carry brick, concrete slab, and machine and many more. Why tower crane are used? Tower crane are used because they are efficient at lifting and moving heavy material and having relatively small footprint on site. So tower crane consists of vertical mast, a horizontal boom or jib, and counterweight. So the function of counterweight is used to balance the weight of the object being lifted. So in our study case, we found that the principle of equilibrium and moment is the static principle that keeps the crane stationary. Lastly, the force on the crane load is equal to the load weight, while the counterweight prevents the crane from falling. So I think that's all from me. We move to the next presenter.
Okay. So next we will go to the next part, which is literature review. So here I stated two references that I found about a high tower crane. So the first one is from Press Darmawan, which is the author that we have been written on 2020 about this article. He said that the theoretical about crane are related with static, which is equilibrium, and top that we have been then implies. Next is from M10 2019. Stated that a working arm is one horizontal jib that is part of a crane carrying a load. So there is a trolley connected to the jib that moves the load along the arm. The trolley is attached a hook that includes motor to be the load lifting control. So I think that's all for me. I will pass to the next presenter.
Okay, next is the mechanism. This is the paragraph that we use to calculate the load. First, the detail is a weight of the air conditioner. The weight is like 2,800 kg. And next is the weight of the counterweight is 9,500 kg. Next is length of the tower crane is 11.1 meters. Okay, next is a draw free body diagrams. To determine the maximum force F max of every distance of the tower crane that tower crane can carry by using same counterweight but different distance and different lengths. To find the value of F max, we must use the principle of moment to find the maximum height. Next. Principle of moment. This is the sample of picture of the formula. The M is for the moment, F for force, and the D is the distance from the pivot, about like point A to point B. That's all for me. Next presenter.
Okay, now we move on for the calculation. In this our project, we use three cases for our calculations. Okay, next slide. Okay, this is the calculation method that we have used for our project. The first one is we calculate the F max for every distance, and then after we calculate that, we will compare the actual F2 force with the F max for every distance to determine whether it fails or not. Okay, the next one. Okay, the next calculation method that we applied is that we also calculated the moment for every distance, for every cases too. Okay, we move on to the next presenter, I think. Okay, thank you.
A tower crane is a common piece of heavy equipment used in construction to lift and transport materials during the construction process. In order to operate safely and efficiently, we must maintain equilibrium. There is three states first is vertical and horizontal equilibrium, second is torque, and then lastly center of mass. Vertical and horizontal equilibrium, the sum of the vertical forces acting on the crane must be zero. This includes the weight of the crane itself, the load it is carrying, and any other vertical forces. For horizontal equilibrium, the sum of the horizontal forces in both the x and y direction must be zero. This ensures that the crane is not accelerating in one direction. And then the second one is torque equilibrium. Torque equilibrium for a power crane involves balancing the torque of motion of the forces acting on the crane to maintain adjustment of our crane. Careful load positioning and consideration of the boom configuration are essential to achieving torque equilibrium. And lastly is center of mass. The center of mass is the point at which the entire mass of a crane can be considered to be concentrated. Ensuring that the center of mass is well balanced is essential to prevent the crane from tipping or become unstable during the operation. And then lastly is conclusion. In conclusion, ensuring that our crane static equilibrium is paramount for its safe and efficient operation. This equilibrium is achieved by meticulously balancing forces and moments acting on the crane. With our joint counterweights and load must be collectively satisfy the condition of static equilibrium to prevent tipping or structural failure. Engineers play a crucial role in designing tower crane with the right dimension materials and counterbalancing mechanism. That's all from us. Thank you.